In this problem, we are given the model to determine the number of weeks t that it takes to have n fish in the pond. That is, we are given 0.2t equals natural logarithm 84n minus natural logarithm of 850 minus n. So this is the model which represents the number of weeks t it takes to have n fish in the pond. And we have to answer these two questions in part A and part B. In part A, we have to answer the number of fish in pond after 10 weeks. And in part B, we have to find the time it takes to become 200 fish in the pond. So let's try to answer these two questions. We'll do the first part now. So in part A, we have to determine the number of fish. So this means we have to basically find n when t equal to 10 weeks, that is t equal to 10. So if you observe the model, we see that it is given in terms of t. So since we wanted to find the or determine the number of fish n, we have to first to solve this or rewrite this equation in terms of n. So let's see how to do this one. I'm going to copy this model, that is 0.2t equals natural logarithm of 84n minus of natural logarithm of 850 minus n. So first I'm going to apply the properties of logarithm, that is if we have logarithm a minus logarithm b, these two can be combined and written as a logarithm of a over b, because the subtraction of two logarithm is equivalent to the logarithm of the quotient of a and b. So in the same way, if I do it, I take the natural logarithm of the first part, that is 84n, over the second part is 850 minus n. So this is my first step. I have this 0.2t over here. Now I'm going to take the e on both sides. That is, I'm going to raise both of this to the exponent e. So I write down like this: e raised to the power of 0.2t, and this I write down as e raised to the power of the terms what we have, that is 84n. We rewrite this. This is 84n over 850 minus n. We can see that on the right side we have this e as well as this natural logarithm will get cancelled over each other, because these two are inverse to each other, and we can simply rewrite this as 84n over 850 minus n. And this side we still have this e raised to the power of 0.2t. Let's continue, and we have to simplify until we just have only n on either of the side. So first I'm going to multiply by this term to both sides, that is 850 minus n. So let me write over here, which means I'll be getting 850 minus n times of e raised to the power of 0.2t. So this is equal to 84n. Now let me distribute this e raised to the power of 0.2t to these two terms, that is like this. So when I do that, I'll be getting 850 e raised to the power of 0.2t minus n times of e raised to the power of 0.2t equals 84n. To solve for n, I have to add this component to both sides. So let me do that. So this side I just have 850 e raised to the power of 0.2t equals 84n plus this term, that is n raised to the power of n times of e raised to the power of 0.2t. Now if you observe on the right side, I have n in both terms of the expression, so I can factor out the n. So I'm going to do it: n times of 84 plus e raised to the power of 0.2t. So this is what I'm getting. And on the left side, I still have this term 850 e raised to the power of 0.2t. Now to solve for n, we just have to divide by this expression so that we can solve for n. So I'm going to do that, and I'm going to rewrite n such that it is in the left side. So n equal to 850 e raised to the power of 0.2t over 84 plus e raised to the power of 0.2t. So this is the final expression for n. That is, from the given expression t, we have converted that into expression for n. Now all that we have to do is we have to plug in these two values. That is, to answer the part A, we have to plug in t equal to 10 into this equation. So let's do that so that we can find the number of fish. So therefore n equal to 850. This is we are plugging t equal to 10 into this equation. 850 e raised to the power of zero point 0.2 times of t. I'm replacing it as 10 divided by 84 plus e raised to the power of zero point 0.2 times of 10. So let's simplify this. This is 850 e raised to the power of zero point 0.2 times of 10 is basically 2. That is, it becomes e squared. And similarly, 84 plus e raised to the power of zero point 0.2 times of 10 is once again it is 2. So it's basically e squared. We can plug this into the calculator now. We just have to multiply this 850 with the e square and divide over 84 plus e square. And when we do that, we get approximately 68.72. So when we convert this to whole number, we get approximately 69. So this is the amount of fish after 10 weeks. 69 fish are there after 10 weeks. Now let's answer the part B. So let's go back and check the part B question. We have to determine the time it takes to become n 200 fish. So basically n is given as 200 and we have to find the corresponding t. So that means we can use the given model. So we are already given the model in terms of t. However, I'm going to use this the simplified form of the same model. In fact, I can also divide by 0.2 so that I have t by itself. So let me copy this first. That is 0.2 t, and write down here. It is 0.2 t equals natural logarithm of 84n over 850 minus n. Let me just confirm it. It is 84n. We have 0.2 t equals natural logarithm of 84n over 850 minus n. So let's continue. We can divide by this 0.2 first so that we just have t by itself on the left side. So this has become a natural logarithm of 84n divided by 850 minus n over 0.2. In fact, this is equal to, if you can consider, if you divide by 0.2, this is equal to multiplying by 5. So I can write down this as 5 times of natural logarithm of 84n over 850 minus n. Now we just have to substitute n equal to 200 into this equation so that we can determine the corresponding time. So I'm going to substitute n equal to 200. So when I do that, I'll be getting 5 times of natural logarithm of 84 times of 200 over 850 minus 200. So therefore this becomes 5 times of natural logarithm of 84 times of 200 is equal to 16,800 over 850 minus 200 is 650. So you can plug this into the calculator. First you divide this 16,800 over 650 and then take its logarithm and then multiply the result by 5. So when we do this, we get approximately 16.2. And when we convert this to whole number, we get 16. So since time is in weeks, we put 16 weeks. So this answers the part B question. So for part A, we have determined that there are about 69 fish. And for part B, we determined that it takes about 16 weeks so that we will have 200 fish in the pond.